students. This is Chapter 6, Introduction to Euclid's Geometry from R.S. Agrawal. So first we starting the chapter. Please go through the link and subscribe the channel. Like, share also. Here the name geometry. Geo means earth and metrion, or you can say metry, METREIN, metrion means measure. So geometry, geo and metrion, it is divided in two parts. It means here we will study the measure of the things which are present on earth and which type of things we have to measure, and who explained such type of geometry, the name Euclid. It is a great mathematician and belongs to Greek. So Euclid is a great mathematician who explained the geometry of plane figures. Geometry of plane figures. So we will study the geometry of plane figures in Euclid's geometry, and it is known as Euclidean geometry. EUCLIDEAN, Euclidean geometry. And the most important thing which we will discuss in Euclidean geometry are axioms and postulates These are two important parts of this whole geometry. Axioms means we will use axioms, true statements. And this true statement will be used to whole mathematics, for mathematics. And postulates are used specific for geometry. Specific to geometry. This is the difference in axioms and postulates. Axioms you can be used in other branch of mathematics also, but postulates we will use to geometry. Now these are the Euclid's axioms, and we will discuss these axioms right now, one by one. First axiom is things which are equal to the same thing are equal to one another. Suppose A is equal to B and C is equal to B. So things which are equal to the same thing. Here A and C are equal to B. It means A and C are equal. So you can write it A is equal to C. Means A and C are equal to one another. Second, if equals are added to equals, the wholes are equal. Suppose A is equal to B. Both are equal and equals are added to equal, and we are adding in A plus C. Here also B plus C, both are equal, means whole are equal. The third is, if equals are subtracted to equals, the remainders are equal. Same as for done add and same here for subtract. Suppose A is equal to B and you subtract equals from both, minus C, here also minus C. So what the remainder you will get? Suppose you get here D and here also you will get D. So remainder are equal. Fourth is, things which coincide with one another are equal to one another. Suppose we are taking a line segment AB and here you divide it into two parts, A, B and this is C, and AB is coincide to AB. It means AB is equal to AC plus BC or CB. Because AB is equal to AB, both will be coincide, its part will also be coincide to each other and both will be equal. Number 5, the whole is greater than the part. Same, it is very easy. This is whole and this is the part, always greater. Number 6, things which are double of the same thing are equal to one another. Number 6, things which are double of the same thing are equal to one another. Suppose AC is equal to 2BC. Things which are double of the same thing, it is double of BC. So here the things are equal to another, means BC is equal to BC. Number 7, things which are half of the same thing are equal to one another. Which are half things? Suppose AC is equal to half BC. Things which are half of the same thing are equal to one another. Things which are half of the other thing, or things which are half of the same thing are equal to one another. It means here two parts of BC, means half BC is equal to half BC. Both are equal to one another. Now come to the postulates. Here are Euclid's 5 postulates. Euclid's 5 postulates. Number 1, a straight line may be drawn from any one point to any other point. This is one point, this is other point. So here you can join this point and extend it in both the direction. Only unique line you will get. So this is the first postulate. A straight line may be drawn from any one point to any other point. See how it is. Straight line may be drawn from any one point to any other point. This is any one point, and take another point. This is second point, and you draw the lines from this point. Suppose you draw like this, extend it. One more line from this, one more line like this. Here, from this point, only one line can pass, or you can form only one line from 2 points, extend it in both the direction. So any 2 points you can form only one line. Now if you are taking this point and draw the lines, so this will, you can draw like this, here also, and to any other point only one line you can draw. So it means a straight line may be drawn from any one point to any other point. Come to the second postulate. A terminated line can be produced indefinitely. Indefinitely means endlessly. And suppose terminated line means line segment has two endpoints and can be produced. You can produce it in both the direction like this. And how much extent? Indefinitely, means never end. Now this shows that a line segment can be extended in both the direction endlessly. Third, a circle can be drawn. Circle can be drawn with any center and any radius. Any radius. You have made the circles of different radius and different centers. So it means a circle can be drawn with any center and any radius. And suppose this is the center, and taking radius and draw a circle. One more circle, you can draw another center like this. One more circle. It shows a circle can be drawn with any center and any radius. Fourth, all right angles are equal to one another. Draw right angle 90 degree. Other right angle 90 degree. Suppose this is right angle 90 degree are equal to one another. Now fifth postulate, if a straight line falling on two straight lines makes the interior angles on the same side of it taken together less than two right angles, then the two straight lines, if produced indefinitely, meet on that side on which the sum of angles is less than two right angles. What is the postulate says? A straight line falling on two straight lines. Suppose here are two straight lines like this. Suppose this is one straight line and this is another straight line. And a straight line falling on two straight lines. This is the straight line which is falling on these two straight lines. Now mark these straight lines. Suppose A, this point B, C, D, this is E, and this is F, and here G, and this is H. Now two straight lines makes the interior angles on the same side of it taken together. We will take two angles and that will be the interior angles. Suppose this and this. These are interior angles and these are exterior angles. So we are taking interior angles taken together and they will be less than right angles. How many? Two right angles. Two right angles means 90 degree and 90 degree means 180 degree. It should be less than two right angles. You can take here also, and this should, and the sum should be less than two right angles. So suppose we are taking here these two angles on G and H, and the sum will be less than two right angles. Then the two straight lines, if produced indefinitely, now two lines produced indefinitely, meet on that side. It will meet on that side on which the sum of angles is less than two right angles. Suppose here the sum is less than two right angles, then it will meet in this direction when you extend it. So where you will get the sum of less than two right angles, this will meet on that side. Okay, so this line extend here and this is also extend, and it will meet on some point, and when you extend in other direction they will never meet. So this postulate says that the two interior angles are taken together and sum will be less than two right angles, and if we produce the lines, they will meet on that side where the sum of angles, or you can say interior angles, less than two right angles. So this is the important postulate. And when you take in the sum in opposite interior angles, or you can say opposite to these angles, and taking the sum of these two angles here, these two angles, the sum will be greater than 180 degree, or you can say the sum will be greater than two right angles, and you extend or you produce the straight lines, they will never meet. This is the concept based fifth postulate. Now come to the next term, statements. Statements means sentence which may be true or false. So statements may be true or false. It is a sentence, not always true. And next term, theorem. Theorem required the proof of statements. So here need the proof of statements. That is called the theorem, where you required a proof of any statement. Next term is corollary. 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 Llary. Spelling C-O-R-O-L-L-A-R-Y. This is A-R-Y. Corollary means a statement which you can easily got from the help of theorem. So that is called corollary. It is also a statement, but easily you can prove with the help of theorem. Now, parallel line axiom. If P is a point outside a given line, suppose this is a line and it is line L and P is outside the line, this is the point P. If P is a point outside a given line, which is L, then one and only one line can be drawn to pass through P. Only one line you can draw, which will be passed through P and parallel to L. So this line is parallel to L and this will be only one line. So this is called the parallel lines axiom. And suppose this is the line, this is L, this is M. This is a point on this line. This is the theorem. Prove that the lines which are parallel to a given line are parallel. Suppose here we have to given three lines, L, M and N are three lines which are parallel to a given line, and it means L is parallel to, suppose, N and M is parallel to N, like this. These are three lines and one is L, this is M and this is N. L is parallel to N, M is parallel to N. Now to prove here this is also parallel to N and this is also, and we have to prove N is parallel to M. Parallel to M. Proof. For proof, suppose we are taking L is not parallel to M. L is not parallel to M. L, suppose here it is, we have to prove L is parallel to M, but we are taking that this is not parallel to M. It means these two lines intersect somewhere when we extend it. So suppose it should be intersect at a point, unique point, so that L and M intersects at P, at point P. Now it shows that through a point P, there are two lines, L and M, L and M both are parallel to N. Both are parallel to N. This part is given in according to question, that L and M both are parallel to N, and in starting we have supposed that L is not parallel to M, but these are separately parallel to N. It is given according to theorem, but two distinct lines, means separate lines, or you can say two distinct intersecting lines. Because when we suppose L and M are not parallel, it means they will meet at the point P, and these two distinct lines and which are intersecting lines cannot be parallel. Two distinct intersecting lines cannot be parallel to the same line. So what we have supposed is not right. So this contradicts the fact. This contradicts the fact. The fact was that two distinct intersecting lines can never be parallel to same line. It means our assumption is wrong, that L is not parallel to M. It shows L is parallel to M. This contradicts the facts. Hence, L is parallel to M. Once again, take a look and discuss. Here, three lines are given, and also given that the lines are parallel. L and M are parallel to N, and we have to prove L is parallel to M. So for that we suppose L is not parallel to M. It means this line will intersect at a point P, but it is given that these lines are parallel to the third line, which is N, but two distinct intersecting lines can never be parallel to the same line, which is N. Two distinct lines which are intersecting will never parallel to the same line. So here we use this point we are using to prove the theorem. But why this happens? Because we supposed that L is not parallel. It means this is the contradiction of the fact. And if this contradiction arises by assuming that L is not parallel to M, it means L is parallel to M. If we will not suppose L is not parallel, then no contradiction will arise. So here we suppose we assume that L is not parallel to M. We suppose it means it is against of the fact, and hence L is parallel to M. Both are parallel to each other, so that these both are parallel to the third line also, N. And according the first axiom, Euclid first axiom, the things which are equal to the same thing are equal to one another. Means the things means L and M are parallel to the same thing means N. It means the things are equal to one another. So L is parallel to M. According to Euclid's first axiom, we can prove it also. So student, this is the introduction of Euclid's geometry, and we will do the exercise 6 in my next video. And you don't forget to like, share and subscribe my video, and comments also. Thank you.